Alright, today we're going to talk about set notation. So set notation is the second way that we're going to learn how to write domain and range. And it's very similar to inequality notation. It's almost the same thing, except there's something added in the beginning. And the reason it's added in the beginning is because of this. So when we define a set in math, we're talking about a collection of things. In math, we call them numbers. Okay? So this is the set that includes 5, 7, and 11. It means it doesn't include any number in between. It only includes those three numbers. Alright, so there's a couple of important sets that we will see these letters. So these letters always mean this set of numbers. So the natural numbers are the counting numbers, meaning starting with 0 that you could count 1, 2, 3, 4, and so on. Integers, which we show with a Z, go from the negative counting numbers to the positive counting numbers. So it means it doesn't include things with decimals, it only includes whole numbers. Then Q is a set of rational numbers, meaning it does include decimals. And then this is the big one that you'll see a lot, especially on standardized tests. This symbol means a set of real numbers. So a set of real numbers would be all numbers from negative infinity to infinity. That's the number line. So anytime you have a point on the number line, it's considered a real number. And any decimal, any whole number, any counting number, any negative number, all are real numbers. And then we have the set of complex numbers, which we'll talk about later in the course when we get to complex numbers. Alright, so a set notation, we call it set builder notation, is because you can build a set describing what's inside of it. So this is how it's read. A, the set A, is equal to X such that, so the symbol right here means such that, and then we define it using the inequalities we learned yesterday. So let's read this one down here. So this, we know it's a set because it has the brackets that are squiggly. I think they're called braces. And we also have this bar in between. So we would read this, or if we wanted to write it in words, it would be X such that X is less than, because that's the less than sign, or equal to 8. Okay? This one, the only difference between this one and this one is that this has this sign. This sign means an element of. E for element. So we're saying that X is an element of the real number system, meaning it has to be a real number. And we can say that X is less than or equal to 7. So we would say X is an element of the real numbers such that X is less than or equal to 7. Alright, so really the only difference between yesterday's and today's is that this bar and this X are thrown in, and we just read it X such that such and such. Okay, so let's see an example of that. So, say we had a graph, let's just do an easy one. It went from -3, 1, and it's going to be a closed circle, to +2, -2. Okay, and let's just make it a line through those dots. So our domain, remember, goes from left to right. So this endpoint here is -3. This endpoint here is +2 on the x-axis. So my domain in set builder notation would be the set of x's such that x is between -3, it's a closed circle, so I'm going to use less than or equal to x, less than or equal to 2. And then you close your set. Now I said out loud x such that x is between. Well, x is between these two numbers, so you can say it that way. You can also read it x such that -3 is less than or equal to x, less than or equal to 2. The range of that function, again, it's the y value, so it would be -2, and then it stops at 1. So we would have the set of x such that x is between -2, it's going to be closed circle, so it's less than or equal to y, because we're talking about range, less than or equal to 1, and then you close your set. So like I said, this is the only difference that we see between inequality notation and set notation. The reason we do that is, say we had a graph that looks like this. It goes up, it's got arrows, and it's got arrows here. Okay? So what I'm saying here is that this graph is going to keep going this way, and then it's going to go up, up, up. Then on this side, it's going to go up, 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 and it's going to go right, right, right. Well, I'm excluding this line right here, this y line, that's 0. So instead of having to write out x's between negative infinity, stopping at 0, going to positive infinity, we can say that x is an element of the real number system, and x cannot be 0. Okay? So that would be our domain of the function. And it's easier to say that we're excluding 0 but everything else is included versus trying to say between the two. Okay? And we're going to practice this one on our worksheet today, or both of these on the worksheet. But when we exclude something, it's easier to exclude one number than to write all the numbers. Alright, so set builder notation just adds in, and like I said, this is just a straight up and down line, and it stands for such that. Okay, so if you're a little confused on any of this, I found this awesome website. It's called mathisfun.com, and you do /set-builder-notation.html, and I'm going to post this on the Sophia website as well, so you can just click on it. But they had some really good information on the difference between the inequality and the set, and then it goes into interval, which we'll talk about tomorrow. Okay, so make sure that you take notes over this video. Make sure you bring them to class tomorrow because we're going to be doing this in class. Have a good night.